What if we had something like 3 square root of x equals the square root of x plus 32? Now, if this were a 3 plus the square root of x, so that this was 2 separate terms, this would be way, way, way harder. But since this is just multiplied, if I square something that's multiplied, I just square both of them. It's when they're added that you can't just square each one. So since these are multiplied, then when I square this, I just square the 3 and I square the square root. So the square in the 3 becomes 9. Squaring the square root just gives me what was on the inside. And then, of course, if I square that side, I have to square this side. And even though these are added, they're under 1 square root. So this is just x plus 32. It's linear. This would be completely different if it was the square root of x plus the square root of 2. This would be totally different. If it's in 2 separate radicals, you have this situation. But if it's all in 1 radical and you square it, it just goes away because one cancels out the other. So this is linear. I want to put the x's on one side together. 9x's minus 1x would leave 8x's equals 32. Divide by 8. X is going to equal 4. And then I have to check. So if I check the x equals 4, then I get 3 times the square root of 4 is supposed to equal, I hope, 4 square root of 4 plus 32. This is 3 times 2, which is 6. This is the square root of 36, which is also 6, which works. There's my answer. Let's try one more, and then we'll talk about 8.6. So let's try this one. What if we had 3 plus the square root, I'm using theirs now, I'm looking at the book, of 27 minus 3x equals x. So the first thing I have to do is what? What's the first thing we need to do here? Somebody? Anybody? Isolate the radical. Means this 3 has to go. So that's out. I've got the square root of 27 minus 3x equals, can't combine those, x minus 3. Now I want to square both sides. I'm going to square that. This one I'm going to have to FOIL out. So the hard side becomes the easy side. The square root squared is just 27 minus 3x. This, you can FOIL it out, or you can use the shortcut. The shortcut says square the first one, multiply them together and double it, and then square the last one. It's quadratic. So I need to set it equal to 0. So subtract 27, add 3x. That'll give me my 0. Let's see, x squared minus 3x minus 18. Factors of 18, been here before. Want the factors that subtract to give 3. So that would be the 3 and the 6. So x and x, 3 and 6. To get a negative 3 out of this, it's got to be a negative 6 and a positive 3. So I'm going to end up with x is a negative 3 or x is a positive 6. And then check. I have to check both these all the way through. Okay, so the original problem was 3 plus the square root of 27 minus 3 times negative 3 is supposed to equal negative 3. This side, that side's done. This side is 3 plus the square root of 27 plus 9. So 3 plus the square root of 36 would be 3 plus 6, which is not going to be negative 3. Is that an extraneous root? If that had been a negative, then this would have been a negative. This would have been a negative. This would have been a negative, and 3 minus 6 would have been negative 3. So this is definitely an extraneous root. The name isn't what's important. It just means that doesn't work. If I check the, what was it, x equals 6, I get the square root of, I get 3 plus the square root of 27 minus 3 times 6 equals 6. 3 plus the square root of 27 plus 18. 3 plus the square root of 15, carry the 1. Wait a minute. Oh, wait, that was a minus 18. That's why. You're going to get a positive square root in here. Let me fix that. Okay, this would be 27 minus 18, which is 9, which is 3 plus 3, which is 6. This side is 6. So this one works. That's the only answer. Now, if you fail to check these and you put both answers into my math lab, it's going to just say it's wrong. And then you're going to want to start all the way back at the beginning looking for a mistake, and there is no mistake. So if you put in an answer to my math lab and it says it's wrong, make sure that you checked your answers. you'll be able to tell from this by changing the sign in front of the radical whether it's a mistake or an extraneous root. Well, let's look at some applications. Doesn't that sound like fun? Here's a problem. On Dwayne's first flight in a hot air balloon, he noticed that he could just see on the horizon a landmark that he knew was 30 miles away from the ground under his balloon. How high was the balloon? So Dwayne is in a balloon. Sees a landmark "30 miles away along the ground." The formula we need is given, okay. They give you a formula in here. D equals the square root of 1.5h. Since this isn't a trig class, they have to give us the formula. Means the distance, here's the balloon. Here's Dwayne hanging from the balloon. We know this distance is 30 miles from below the balloon to some landmark. I don't know, a tree. He knows for some reason this tree is 30 miles away. I'm sure it's not a tree. And they're giving us that the distance here is the square root of 1.5h, where this distance is h. So this is going to make use of the Pythagorean theorem because it's a right triangle. That's the one where it says a squared plus b squared equals c squared in a right triangle. So if this distance is 1.5 times this distance, and make sure I've got the sides labeled correctly. The distance is for, the formula is for the distance you can see to the horizon. So he's looking at the horizon, but okay. I misunderstood the way they're putting the distance in. I should have read the example before this. Haha. Okay, this distance is the square root of 1/2 h or 3/2 h. Or let me go ahead and write it as 1.5 times h. This distance, if you were standing down here, would be h. Now that's d. The formula we need is given above the example. The example was on a different page, so I hadn't seen it. Okay, this distance is the distance you'd be able to see to the horizon if you were standing directly below the balloon. So the distance here is 1.5 h. So what they've got is, this is not going to be the 30, the Pythagorean theorem. The next section is, if the distance is the square root of 1.5 h, that's just the formula given in the problem. And d is 30. Then we've got 30 equals the square root of 1.5 h. But to solve this, you're going to square both sides. Thirty squared is 900 equals 1.5 h. The square root squared cancels out. Divide by 1.5, that's going to be a calculator problem. And 900 divided by 1.5 equals 600. $600 equals h. Oh, this was h. Duh. So h equals 600 feet. He's 600 feet up in the air. This is basically a trigonometry problem. So if you've taken trig in high school, you know that you're talking about the cosine of this angle is h over d, and it's going to be, that's where they get all this. Somewhat beyond the scope of this class. We have to be given the formula in order to do this problem. And a better example would have helped a whole lot. But in section 8.6, everything is based on right triangles. It's actually going to be a lot easier. (8.6) is going to be applications using right triangles. These are easy because you know every one of them is going to involve the Pythagorean theorem. Where you've got a right triangle, any triangle that's got a right angle in it. And if you label the two sides that make up the right triangle A and B and the long side C, it's always going to work out that A squared plus B squared equals C squared. Now, knowing that A squared plus B squared is not the same thing as A plus B squared, you cannot just take the square root. And get rid of the squares. So let's say you've got any right triangle where you know two of the sides. You can always find the third side. If this is 5 and this is 8, what is this side? Most of the time, these are not going to come out to be pretty numbers. Here, in this case, we'd say 5 squared plus 8 squared equals C squared. This, of course, is C. This would be 25 plus 64 equals C squared. This is 89 equals C squared. So C squared is going to be the square root of 89. Or therefore C is the square root of 89. If we bring up the, let's see, this one got a square root, yes. If we bring up the calculator here, if they want an approximate value, and let's see what they're usually doing as far as how far to go. Looks like they say to go to the 1,000th. This is your exact value. If we do the square root of 89 in the calculator and go 3 decimal places as they asked, when you go to 3 decimal places, can you all see the calculator? To go 3 decimals, as they asked, thousandths, so you've got tenths, hundredths, thousandths. When you're going to round off, look 1 decimal beyond where you're going to round. If this is 0 through 4, just cut it off. If this is 5 through 9, you round this one up. So you'd make this 9.434 to go to 3 decimal places. In word problems, they will usually ask you for both the exact value and the approximate value. The approximate's where it's rounded off. And they have to tell you how far to go to round it off. Let's say we've got a triangle where they give us one of the sides and the hypotenuse. And they want to find the third side. Now these two, you can let either one of these be A and B. These are interchangeable. The long one has to be C. So if we call these A and B, A squared plus B squared is C squared is going to give us 4 squared plus, don't know that one, squared equals 15 squared. 16 plus b squared equals 225. If I subtract the 16 from both sides, it means b squared is going to be 209. So b is the square root of 209. This is our exact value. Calculator, square root of 209 to 3 decimal places, which is what they were asking for. We've got 4, 5, 6, 8. The 8's in the big half, so it's going to be 4, 5, 7. So B is approximately 14.457. That's the approximate value to 3 decimal places.